Okay, I'm sorry about my audio. Somehow it's not working very well. It feels like I am sick when I hear my recordings, but I am not sick, I promise. So somebody asked me, what is the Thevenin equivalent and what's the Norton equivalent? So if you are asked, what is the Thevenin equivalent? Really, I'm asking you two questions. What's VTH and what's RTH? And I, in principle, expect you to draw that circuit this way. A voltage supply in series with a resistance. So it's a V, and usually it's a plus on top. And that's the voltage, Thevenin voltage. This is the Thevenin resistance. If I ask you for neck, the Norton equivalent, it will be a current supply in series with a resistor. IN in series with RN. RN is the same as RTH. VTH is that resistance times that current. This current is that voltage over the resistance. So the two of them are source transformation of another. If you get a simple enough circuit, and this is a simple enough circuit, and I apologize for the level here of bad drawing, but there's 5 milliamps going up, 30 going down, 15 going up. I'm gonna say that going down is the main driving force here of this current. So I'm going to simplify the circuit without ever finding the Thevenin or Norton equivalent. But I'll show you how to find it without, actually I take that back. I'll just simplify it to the Thevenin or Norton equivalent of the circuit without following the rules that we had in class, which are turn off all power supplies and find the equivalent resistance. And then leave the power supplies on, put ground on B, and find VA, that's VTH. I'm going to instead only simplify this. And now look, there's 14 kilo ohms here in parallel with 35 kilo ohms here. It turns out 14 in parallel with 35 kilo ohms. You could do this in, you see how 14 is 2 times 7? Actually, let me do this separately. So I want to do 14 times 35 divided by 14 plus 35, and I know that this will be in kilo ohms. This here is a pretty painful math problem if you don't use common denominators or common factors. So you could do this. This is 2 times 7, and this is 5 times 7. And here there is 2 plus 5 only times 7. So as you see, 2 times 7 is 10 times 7 times 7, and here 7 times 7. So it turns out the parallel resistance of 14 and 35 is 10. I hope this is right. 10. So I'm gonna make here a 10K resistor. And back to the 5 milliamps going up, 15 going up, 30 milli going down. That means it's 10 milli going down. And the rest is going to be the same, 2K, 5. And I'm swapping the signs there. 7. Swapping the signs and swapping the power supply. Now I'm going to do the same thing. I'm going to simplify by doing source transformation on this one. And the 10K is going to stay the same. 3K and 2K is going to stay the same. So it's going to be a 15K resistance. And the power supply will be plus on the bottom. 10 milli times 10K is 100 volts this way. 5 volts this way. And 7 volts the opposite way. So what happens is finally, I apologize, my Thevenin equivalent will be 15 kilo ohms, and there will be just one power supply, and this power supply will be plus on the bottom. It's 105 minus 7. This is plus on the bottom. 105 minus 7 is like 98, I think. Actually, I don't know. 98 volts. So this here is the Thevenin equivalent. Instead, if I want the Norton equivalent, it would have been the arrow going down, and this would be 98 divided by 15, which is 6 point something, 6 0.6 milliamps in parallel with 15 kilo ohms. I hope this helps explain what Norton and Thevenin are. Thevenin and Norton for simple circuits. And I'm going to post this video.